Hey folks, I've had some requests for some additional example problems using projectile motion, so here they are. Here's a nice exciting one to practice with. We've got some sort of an action movie where the cars are driving around on the rooftops and maybe there's rockets involved and probably anti-gravity and lots of real life physics stuff like that, as most action movies have. Yeah. So the question here is based on the situation described, how fast does our car have to drive in order to make this jump? First step on these is to picture the situation. This is the basic situation. We've got our first roof, which is 12.1 meters high off the ground. The second one is 9.2 meters high off the ground. And there's a distance of 4 meters between these two. And it asks about the minimum speed, so that means that we're not going to make it by a wide margin. We don't have the car landing way over here. We're going to have the car right on the edge there, so that 4 meters exactly for our horizontal distance. So after we've got our sketch on this one, we're going to go ahead and fill in that list of variables that we might be working with here. We've got these 11 variables that we might know something about or be asked to find. We can always fill in the acceleration. In the x direction is 0, and in the y direction is negative 9.8 meters per second squared. That's coming from our definition for a projectile, that gravity is the only force acting on it, so the only acceleration is going to be that due to gravity. We've got some positions outlined here. The x position, it doesn't really tell us where in the horizontal direction it starts, just that it needs to go 4 meters. So we might as well use 0 for our starting position and 4 meters for our ending position. There are some distances given for y naught and y, so we could use the 12.1 meters for y naught and the 9.2 meters for y. We're going to end up though with just caring about the difference between those. So if you didn't want to use the use the ground as our 0 point, then you could certainly change these numbers as well. And I think that makes sense. I like to have as many zeros in here as we can, drop out as many of these terms as we can, and that eliminates some chance for some little mathematical mistakes. So on this one, let's say that it's going to end at a height of 0. So this roof here is our 0 height. And then the other roof is 12.1 minus 9.2 is 2.9. So the other roof is 2.9 meters up. That'll be our starting position. It says it's going to be driving off horizontally. That means it's not moving vertically to begin with. So we have a Vy naught of 0. And we're asked how fast in the horizontal direction it needs to be traveling in order to make that jump. So we don't know anything about Vx or Vy or t yet. Next step, we got to figure out what equations we can use to get to that Vx naught. There are 3 equations that are given to us for kinematics, and we can use each of these 3 equations either in the x direction or in the y direction, not both, or at least not both at the same time. So we have to keep those variables separated. I see that I'm looking for a value in the x direction here, the Vx naught. So I'll start by seeing if there's a way I can just go straight to that. So I need an equation that has Vx naught in it, or V naught over here, and we'll just have the x subscript. So the very first equation has that in it. Let's look at what else is in there and see if we have enough to solve. Let's see, the final velocity in the x direction would be needed in order to figure this one out. And, well, we don't know what that is. And really, we know that these 2 values would always be the same. So if we know one, we know the other. But we don't know the Vx here. That would be a little too easy, I suppose. Let's see, what else do we have? This one, we would need to know this ending position, 4 meters, we've got that. The starting position, 0. The starting velocity is what we're looking for. We'd need to know time, which we don't have. Acceleration we've got, but we don't know time. So before we could solve that equation, we need to know time. Down here, let's see, I could solve for the starting velocity, but I'd need to know that ending velocity again. I don't have that. So it looks like this is the equation I'm going to want to use, but I can't use it until I know what t is. So let's take a look over at the y side and see if we can use that information to solve for t as our first step. So we'll get to this, but we can't do it until we get to t. And it looks like the equations that don't work to find t the equations that don't work to find this one probably won't work to find t also. So x side we'll put on hold for now. Let's take a look at the y side. The first equation there, if I wanted to solve for t, I'd need to know acceleration, which we know, starting velocity, which we know, ending velocity, oh, don't know that one. Okay, let's see what else we got. If we want to solve for t in this equation, I'd need to know the starting height, the ending height, got that. The starting height, got that. Initial velocity, we've got that. Acceleration, we've got that. So it looks like this is our equation, and we'll use that in the y direction. I don't like to do any plugging in of numbers until I've done the algebra, with the exception of zeros, because they make the algebra easier. So I'll plug in zeros every time I see one. I've got a 0 here. Y naught isn't a 0, so I'll just leave that as a variable. Plus, let's see, we've got the v y naught is 0, so this whole term is going to be 0. 0 times t is just 0. Plus, no more zeros, so 1/2 ay t squared. Then I need to rearrange to get t all by itself. So I'm going to leave the term that has t in it alone for right now and get this term out of here. So let's subtract y naught from both sides, because hey, why not? Y naught equals 1/2 ay t squared. Then I'm going to multiply both sides by 2 to get rid of that 1/2. Divide both sides by ay. So times 2 and divided by ay times 2 and divided by ay. There we go. So we got t squared is equal to negative 2 y naught over ay. And then we can square root both sides to get our time is equal to plus or minus square root of negative 2 y naught over ay. Now it doesn't make sense to have a negative t, so we're just going to use the positive value for that. And if I look back at my given information, I can plug in what I know now. I'll have the square root of negative 2 times 2.9 meters divided by, and this is all in the square root, negative 9.8 meters per second squared is equal to t. And so when I type that into the calculator, then we get t is equal to 0.769 seconds. And so we'll take that value and put it back up here with our given information. It's 0.769 seconds. Okay, and let's reevaluate now. We were trying to figure out how fast the car would have to be moving when it left the first roof over here in order to make it to the second one. We found that if it's going to be starting at this height and ending at this height, it's going to fall that distance in 0.769 seconds. That means it also has to go horizontally 4 meters in 7.69 seconds. So now I have the time for that to occur. I have the distance. Now I have enough on the x side that I can figure out what that initial velocity is going to be. So I'm going to use the equation then that our final position in the x direction is going to be equal to our starting x position plus starting x velocity times time plus 1/2 times the x acceleration times time squared. Starting position we said was 0. Acceleration is 0 as well, so just position is equal to the starting x velocity times time. And if I rearranged here, I'd get x divided by t is equal to vx naught. So at this point then, we can solve for vx naught. I'll plug in my x is 4 meters. The time is 0.769 seconds. And that's equal to our vx naught. And that'll get us a value of 5.2 meters per second equals vx naught. And I like to write that out in a statement that goes back to the original phrasing of the question. What's the minimum speed at which the car needs to drive horizontally off the roof to make the jump? So I will write that then as the minimum speed is 5.2 meters per second. That's it for this problem. I'll post another one later this weekend and send out a link for that.